This is the design patterns activity. I'm going to do this in Java. Theoretically, it'll apply to any of the languages, but I'm going to choose Java, partly because of the 4 languages, Java is probably the hardest to implement these patterns. They're going to look slightly different, but at the white belt level, I'm not really interested in you worrying about knowing how to implement all of these in all of the different languages. Really, I just want you to get introduced to the idea of design patterns. This is a little bit of extra after you've done your research. You have done your research, right? So after you've done the research for this activity, I'm going to take you through and show you kind of what a few of these patterns look like, and I'm going to choose 3 of them today. So that's the idea of what I'm doing here. I've got my Java project open. I do need to change my runtime, so let me change the POM XML. I have version 23. We'll save that off, configure or synchronize. All right, we are good to go. So let me open up the app.java file here, just create some room. Basically, I've just got some space where I'm going to create some code that implements and uses some of these patterns. Now the patterns are going to cross files, and so that's, again, one of the reasons I chose Java is it's the most intense in terms of implementing these design patterns. So let's start off, I'm going to start off with a fairly simple one. We're going to use a strategy pattern. And I'm going to use a strategy pattern to, let's say I'm going to calculate an average rating. So let's say we've got a website that has products or services that people can rate. And so they give us ratings 1 to 5 stars, and we want to be able to calculate those ratings. Now, if you've been paying attention to the way any of the movie sites work, they don't always use all of the ratings. Sometimes they discount ratings, especially if they can detect that they may be from bots or from malicious users, things like that. So that's the idea here. We want to calculate ratings, but we want to be able to change the way we do those calculations in case we find a problem. So we're going to use a strategy pattern to do that. In order to do that, I'm going to need to create a few different classes. So I'm going to start off, and I'm going to create a new class, new file, and this will be our base strategy. So we'll call this the rating calculator class. Move that into the same folder. There we go. So here's our rating calculator class. This is going to be an abstract class. And the rating calculator class, since it's our base class for the strategy, needs to define the strategy method. So we'll create an abstract method, and this is going to return a value that is the rating. We'll do a double, so we'll do a floating point number that represents a number between 1 and 5 for our average ratings. And we'll just say calculate rating based on incoming star ratings. So again, I could this is going to vary depending on what my actual code looks like. Let's just pretend that it's an array of integers. Again, 1 to 5. So I have a bunch of integers that are coming in that are my actual ratings. So there is my abstract class. So this defines my strategy. And what I need to be able to do is create specific versions of this for doing the actual calculations. So we'll right click, we'll say new file. And let's just do a simple mean rating calculator. And the simple mean, we need to extend the rating calculator. And now Visual Studio Code is going to help us out. It's going to tell us that we need to add some unimplemented methods. So let's go ahead and do that. And let's convert to tabs. Looks a little better. Excellent. So this strategy, the way we're going to calculate this is we're simply going to take a mean of the values. So for each of these ratings, we want to average them out. So we're going to sum them all up and divide by the total. I'm going to do this very, very simply. I'm not going to try to do it very complex. So basically, I'm not going to do a lot of error checking, things like that. All we really want to do is get these ratings and sum them up. So let's create our sum starting at 0. And we already have the counter, the length that's in an array. So let's just iterate over these values. For each rating of ratings, I'm sorry, not of, colon, we're going to sum the rating value. And then finally we return the sum divided by the ratings dot length. So that's all there is to it. That's a simple mean. We're just taking the sum dividing by the total, or the count. Now let's create another version. And we'll do this one as, let's see, what do we want to do? Let's remove the lowest values. Remove any ones rating calculator. So we're simply going to ignore any ones. I wouldn't really do this in the real world, but let's just create a different one so we can see how this works. So again, we're going to implement our unimplemented methods. And convert to tabs. Let's clean up our file a little bit. So here, we're going to do basically the same thing. In fact, I'm going to copy this. And all we're going to do here is we're going to do a check. If the rating is greater than 1, then we do the sum. Otherwise, we don't do the sum. Now we could end up with, now we also have another problem, and that is we don't want to do by the total length. So let's do a count of how many objects through which we actually go. Now we could have a divide by 0, but again, I'm not going to worry about that for now. This basically gives us the rating. So we've got two different strategies here. So in my actual code, the way we might use this, so this is a strategy example, I would create a rating calculator object. So this is the base class. I'll say calculator equals, and then I would pick the specific rating calculation that I want to do. So I'm going to do a simple mean, and then my rating is going to be from that, and we'll say calculate ratings. Let's just do a new integer array of 2, 3, 5, 3, 1. So there's our rating, and then I can just display this out. So that's the strategy pattern. Now, what's nice about this, and the reason it becomes a useful pattern, is again, inside our code, if we decided we wanted to use a different pattern, the only thing I'd have to change in all of this is this line right here. I would change it to remove any ones, and now I'm using a different calculation. So that's the way the strategy pattern works. Very, very useful in certain situations in the real world. So for our next one, let's use a singleton pattern. So the singleton pattern is a very interesting pattern. I'm going to use this to represent, let's represent configuration. So we've got configuration values in the application. I don't want to have to go to a bunch of objects and try to retrieve those and collect those every time. We're going to use a singleton class to do that. So let's just call it configuration.java. And the way this works is we're going to hide the constructor. So we'll say private configuration. So nothing outside of this class can create a configuration. So we're going to hide the constructor. Then we're going to expose the only instance of this as a static property. So we'll do static properties, public static configuration instance. And right, we're in Java. So we'll say get instance. And we'll need our single instance. So we're going to create this instance as a static version. So in other words, there's a static instance. There's one and only one for the entire app that is going to be the only instance of this class. So we are creating an instance of the class, but we're holding on to the only instance. And here, get instance simply returns the static instance. That's it. And then from there, we can add additional methods of whatever we need to do that we normally would. Let's say, for example, we needed a connection string. So we could say public string, get connection string. And this might return some connection string. So again, using this, let's see how we would use this. Inside our code, we might say, all right, I need my connection string. We're going to go to the configuration class. And we want to get the instance, the sole instance, and then we want to get the connection string. So there's the sole instance, one and only one of it. So it was already created, now we can get that value. And again, we can use it. I'll just print this out to the user. So there's our connection, or our configuration. So the singleton pattern allows us to create a single instance of something so that we don't create a bunch of objects and then create problems for ourselves. It is useful in certain situations. It's not terribly useful all the time, but that's basically the singleton example, the singleton pattern. So let's do one more. Let's do a little bit more complex one. We're going to do a factory pattern. So for a factory pattern, let's say that we have the need to save records off in different formats. So we might want to save them in JSON files, in XML files, and CSV files. So because of that, that's a lot of different forking logic, a lot of different branching, if statements, switch statements, things like that. So with the factory pattern, we can simplify things quite a bit whenever we have a complex scenario like this. So for the factory pattern, the first thing we need to do is define our base factory class. So I'll create a new class. And this factory is going to basically be the data format that is going to be used to generate the objects that actually transform data. And again, there's several different ways to implement this, just like in most patterns. I'm simply going to choose this way just so we can see what this looks like. So this will basically be our data formatter. Try to think, names are always hard. So we're going to use a data formatter. This is going to be a file format specification. So let's do that. We'll say file format specification.java. Now this is going to be an abstract class, and that's part of the pattern. And on our abstract class, we need to be able to create the specific formatters for certain data types. So let's say we have an account object, so we want to create a public abstract account formatter. Now let's say create, just so it's a little clear what we're doing. So we'll create the account formatter. This is going to be an account formatter class. In addition, let's also do a customer formatter. I'm not going to do too many of these, but I do want to do at least a couple of examples so we can see how this might work. So we've got account objects in our code, we've got customer objects in our code. Now these two classes also need to be implemented. So let's create these. We'll create an account formatter.java. This will also be an abstract class. And this class is going to basically format account objects. So we'll say public abstract, and we'll say void, and it's going to, let's see, we'll say format account. Let's be a little more specific. This will be write account to file. And so we'll take the string account, I'm just going to make it a string, and then we'll also say string file path. So there's our formatter. Now we're also going to need to do the same thing for a customer formatter. And it's going to look very similar, but that's just a coincidence. So customer formatter.java, also abstract. All right, so there are the base types. Those are the abstract types. Now what we need to do is create the concrete types. So starting off with the account formatter, I need to create specific versions of the account formatter. And I'll just do one, let's do a JSON one first. So this will be, let me make sure I'm creating it in the correct folder. Okay, I'll just have to move it. So this will be the JSON account formatter. And let's move this here, yes. And so this will extend the account formatter. And what this class needs to do is return. Oh, I apologize. I did the wrong class first. Let me back up. We are going to need to do this. I wanted to do the file format specification first. So let's create a new file. This is the JSON file format specification. And since file format is a duplicate, let's just call it JSON specification. So this will extend the file format specification. Now from here, we do need to implement our methods. We've got two of them. So create account formatter. Since this is JSON, it's going to return a new JSON account formatter. And then our customer formatter is going to do the same thing, return new JSON customer formatter. Now the account formatter, I already started creating the JSON account formatter. So here we just need to write the file out to as a JSON file. And I'm not going to actually do that. We'll just say writing a JSON file. Now we also need to do the same thing with the JSON customer formatter. This will extend the customer formatter. Add our unimplemented methods. This is a lot of code. So again, we'll just print out a line. All right, so that takes care of that. I can also create XML versions. That would be 3 new classes for XML, CSV, 3 new classes for CSV. I'm not going to do that yet, or I'm really not going to do that now. It's just the exercise is already going on long enough. Let me show how to use this. So now what we can do is we can create our file format specification. And then here we can decide which file format. Now right now we only have the JSON specification. But then once we have that, if I have my account, I can now write this out. So I can say var account formatter equals file format specification, now to create count formatter, and then account formatter dot write account to file. Here's my account, and then my file path would be my file.json. So let me expand this so we can see that. So now we have our code to create the file that we want to write. Now the JSON wouldn't be hard coded, but that would probably be something passed in. But again, if we needed to change this to a different formatter, instead of JSON, if I create the other classes, I can do an XML specification. I didn't create that class, so I'm getting red squiggles, but you get the idea, right? Or if I want to change it to a CSV, I could create a CSV specification. All the rest of my code basically stays the same. And so that's the idea of the factory, is it allows us, very similar to the strategy pattern, but it's a little bit bigger. So it allows us to create derived types so that we can use those to do specific things for specific types. So those are just 3 of the design patterns I chose to implement. There are 23 of the Gang of 4 design patterns. I would encourage you to explore these over the next several weeks and months. Some of them are very, very complex, very difficult to understand. Some of them are very, very light, easy, and simple. So some of them you can overthink. Some of them, though, you might want some help. But please let me know if you have any questions. Hopefully this helps. But that will conclude the design patterns for Java.